right, we're going to go ahead and get started. I'm going to go back through all the rules, partly because maybe you've forgotten what we're judging on, but also maybe partly because we didn't do a live stream of it the first time. Okay,
Just before
cool.
Lisa begins, welcome back to those of you watching on the live stream. This is bitcoinplusplus, where the developers, some of the smartest minds in Bitcoin, have been hacking away for the last 24 hours. I'm very excited to see what they've been building. But first, yeah, Lisa's going to go through the judgment criteria and a few other little details. Thank you very much for joining us.
Great. Okay. So for those of you who remember, those of you who don't remember, I should say, the judging criteria, we're going to base it on women's gymnastics grading with a little bit of extra. So there are 3 categories that we've asked our judges to use to evaluate projects on a 0 to 10 point scale for each one, and then we'll find the average. Those are going to be your routine difficulty. So this is how difficult is the task that you set out to do. And then routine execution is how well did you actually execute on the tasks that you set out to accomplish. And then the last one is general effects. Basically like what your style points, right? A little bit of judge's discretion to reward more points depending on the maybe creativity and general flair of the presentation. Great. Okay, so those are the judging criteria. Who is going to be passing judgment on your projects today? We have none other than the Austin BitDevs panel. So very happy to have our local BitDevs moderators showing up for us, which is great. Great. It's Justin Moon, Ben Carmen, and Buck Purley. So super excited to have those guys. Prizes for those of you who have forgotten the incredible prizes we're giving out. First thing is eternal glory and bragging rights. After that is recognition from your peers for second. And third is going to get congratulations from everyone in attendance. But if that's not enough, understandably, first we'll also be getting, oh, you guys can't see, 100 testnet bitcoins. Did I rate that? That seems higher than, all right, yep, we're giving out 100. 500 Signet test coins to second place, and third place is going to get 1,000 Mutiny net coins. So, depending on how these appeal to you, maybe tune your performance as necessary. And then, it'd be nice to get some sats also. So we're giving out 4 million sats to first, 2 million sats to second, and 1 million sats to third place. Cool. So, of course, I need to give a shout out to our sponsors as a thank you for helping make the hackathon here possible. That's Folger Ventures. That's loud. Folger Ventures, who invests in early stage startups, particularly focused on the Bitcoin and Lightning Network. I think we're getting the. That's cool. Great. We're also sponsored by Trammell Venture Partners to help Bitcoin founders build iconic brands at the emergence of a new monetary order. So thanks to both of them. Great. And then we have one final kind of, oh wow, okay, I'm just going to put these up on the screen. So we have Folger, and thanks to Trammell Venture Partners. Last year's hackathon, so before we start going through your presentations, last year's hackathon winner, does anyone remember who that was? Prisms got first. Prisms is a Bolt 12 offer thing where you can send a Lightning payment to one node and it'll get sharded out to a collection of people behind the scenes. We did not pay them out last year because I told them that I would, if they wanted to, pay them out over their Prisms thing so they could get all of the money to all of the team members in one nice atomic thing. I have word that they have finished it. So what we're going to try to do, fingers crossed that this works, is do a payment, or actually do the payment for last year's hackathon using the mainnet Prism implementation, which my understanding is a thing now. Okay. So in case you weren't aware, last year the prize was $2,500, which I did not peg to sats. So we took the, yes, we did take it to the sats. Just kidding. Wait, that's what's happening. We did peg it to sats. So what we did is we took the price at the day of the win, and we divided it by the price to get the number of sats that I owe them, which I believe is now 8 is that 8 million Satoshis? 8.5. Great. So what we're going to do now is I'm going to hop over to my handy dandy terminal, and I'm going to attempt to get an offer from a Lightning node. Okay, so we're going to fetch an invoice for, this is an amount of sats. I believe everyone can verify here is the same number as this, maybe? No. Oh, on this one.
There it is.
That looks good. I think that looks good. Okay, so we're going to fetch this invoice. So now I get an invoice. I'm going to be a little, we're going to decode the invoice. Oops. Decode that guy. Okay. Oh, I can't read that now. But I think the thing I want to check is that it's for the invoice request is the right amount of Satoshis, right? So before I pay it, I just want to make sure I'm like, know what I'm saying yes to paying. Okay, great. And everyone does this, right? You get an invoice, you check that it says it's going to pay what you think it's going to pay, right? Everyone? Okay, yeah. Okay, great. So that's there. So I think all I have to do now is turn this decode keyword. Ooh. Oh no, I did the wrong thing. Okay. Decode keyword into the word pay, I believe. Hopefully this just works. Yeah, complete. Okay, so successfully paid Bolt 12 offer. Is it going through? Okay. Oh, hey, is that it paying out the, so Derek is holding up his laptop and it's paying out the, if you want to come plug into this here, Derek, we can get you up on the live stream. I think there's a HDMI cable here at the front. Sorry, maybe we could have planned a little better here, but it's prisming, yeah. So, all right, I believe my side of this is done, so that's great. Yeah, we did it. We made it happen. Cool. 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 Let's see. There we go. Okay, what are we looking at here, Derek?
These are the incoming stats here. And what we do first is we have all of the Prism members and we update their outlay value first and we persist that to the database. And then we start paying out individual members, and as they're paid out, their outlays are decremented, including the fees paid, so that over time the fees are paid by the remote destination. But so you can see the member outlays are here. And then you can see that we're paying out individual outlays here in the Bolt 12 Prism payment. We actually do have one member that is a key send recipient, so we do support that. And then it looks like here, these are the new outlay values. So you'll see here we actually do have it looks like 2 nodes that did not get paid, but we're tracking their outlay values, so eventually they'll get paid out when their nodes are back online. I did know one node was offline, but he didn't respond by the time we made the payment. So, yep, that's it. Yep.
Cool. Okay, so we're gonna go ahead and now that you know what the stakes are for winning a hackathon, here let's get our first person up to present, which I just posted in the Telegram, is Bitcoin Link. Okay.
Okay, sweet. Wow, what is up? Bitcoin plus plus. Hello. Yes. Let's go. I'm so excited. Oh my gosh. Wow. Okay. So in the history of all the Bitcoin plus pluses, I have a tradition, and that tradition is on presentation day, we are ripping it on mainnet. So this is live. You can go to bitcoinlink.app. I started building this yesterday. And I'm going to tell you what I built, and I'm going to walk you through a very quick demo, and then I'm going to say a few other short things about it. So Bitcoin Link, it's like Riverlink, but it's open source and non-custodial. So I saw Riverlink recently. A lot of people were excited about it, and I thought it was a cool idea. And I thought that I could do this in kind of an open way, in a non-custodial way, with Nostr Wallet Connect, but also with some other methods that are definitely possible. But for my MVP, I started with Nostr Wallet Connect. So let me just show you. Let's go over to it. So this is Bitcoin Link. And so what you can do is you can create a number of links, and you can have sats per link. And currently, Mutiny, I actually need to refresh this. Yeah, Mutiny is disabled right now, because I had it working yesterday, but it broke. So we're going to use Alby. And I'll just create 2 links for, let's say, 100 sats each. And so I can generate a Nostrwall Connect right here very quickly. All right, cool. And I have these 2 links now. And so now I can send these to my friends and give them sats directly from my wallet. So let's copy this link, and we'll go over here. OK, sweet. So it says this link is unclaimed, and the amount is 100 sats. And I can just enter my Lightning address here, use my Stacker News Lightning address. We'll claim. And this is the part. OK, it says the payment is sent. Let me check Stacker News here, because that's the Lightning address I used. 5 seconds ago, received 100 sats. So sweet, so that works. That's basically the full demo. And so, yeah, coming soon, I want to have more ways, to onboard people by giving them these links. So eventually, I want them to be able to deep link into wallets and instantly have a wallet set up and be able to claim the sats. So that is something I'm going to be working on. And I just have 2 more slides here. So a little bit about how this works and how it's non-custodial. Basically, you have the browser, which is generating this encryption key. And when we generate the Nostr Wallet Connect, we do it in the browser state, and we encrypt it with a key that we do not save or store. And we send the encrypted Nostr Wallet Connect to the server. And so then it's kind of like a 2 of 2. The link together, and then the link talking to the server together can decrypt it, and then it can do the payout over Nostr Wallet Connect. So it happens pretty seamlessly. You just pull the encrypted NWC locally, you decrypt it, and then you're able to spend instantly. And so that's kind of the simple scheme that's going on here. And so some problems here is a 2-sided marketplace problem. Nostr Wallet Connect, there's only these 4 really wallets that currently support, as far as I know, support Nostr Wallet Connect for creating these links. But for redeeming, you can redeem with any Bolt 11 invoice or Lightning address or something like that. So I think on that receiving side, that's where we could really orange pill people with a tool like this. And so 2xTM, these are things I want to work on, is being able to send on-chain Bitcoin links via PSBTs, being able to claim funds in the browser via eCash, deep linking into Mutiny to spin up a new node and kind of onboard a user instantly and have them be able to receive instantly. That was something I was talking to Ben about. I think that would be really cool. Cash App is about to have Lightning address very soon. So I think this will be possible to deep link into Cash App and just pay people out instantly. And then building automated Bitcoin rewards kind of services into the API, so other people, if they just want to reward their users easily with a single link, they'll be able to create and manage those and just kind of use the service and not really have to trust me with custodying their funds. And so that's it. Thank you.
I think we're definitely a little over time, but that's my fault for not having a clock. Do we have any questions from the judges about this? Maybe 2 questions max, just because we're tight on time.
Was the only issue with Mutiny the thing you showed me?
Yeah.
Okay.
Yeah, so I just disabled it for right now. We can create Nostr Wallet Connects with Mutiny with Nostr Wallet Auth, and it's an amazing spec, and I love it. But there's something wrong with the payouts, and I didn't want to risk it. So coming back soon.
Great, thank
Sweet.
you. Next up, we have Roy G. Biv. Let's go.
Can you hear me? Okay, great. My name is Derek Smith. I go by Farscapian on the internet. We are Team Roy G. Biv, coming back from last year. We have Michael Evans on the team doing visual upgrades, UX designs to clams. We have UX and diagramming done by Money. And we also had Jana, who's not with us up here, but she was helping us write some writing and do some diagramming. Okay, what are we trying to solve here? We have a problem. We just did the Prism payout, but this involves, unfortunately, so we have a 3-person Prism here as an example. The issue is we need to have a third party, essentially Aaron up here, receive the payment and split those downstream. What we really need is an ability for Bob to host the Prism and then pay to himself so that we can get rid of Aaron here in the involvement. So what we've done here is we've implemented what we call pay to self in the Prisms. There's two different ways to do that, what we call implicit and explicit, but we've enabled a demo environment such that Bob can receive the Prism payout and then also be part of the Prism member, essentially, so he can pay to himself, and we eliminate that need for the third party. Okay, so what is needed? The solution is pay to self. This allows a Prism member to host the offer, and importantly, this enables what we call local Prism composability, meaning that if we can pay to self using the explicit method, that is to pay to a Bolt 12 offer that we ourselves have issued, then we can start composing these prisms together. So you might imagine a payment coming into Prism A, and then Prism B might be a member of Prism A, and so 50% might go down there, and then it gets split out again. And this is all local to the Lightning node. So the next thing we're going to do is a short demo, and I'll hand it over to Michael here.
Okay, we're looking at Clam's popular open source wallet. We added a Prisms tile. And if you go in here, you can see your Prisms list at the top and your offers, and you bind a Prism to an offer. Now let's look at our Prism here. So we have 3 people in this Prism: Carol, Dave, Aaron, and outlay percentage. So this Prism will keep 20% for Bob and then give 80% to everybody else, even split. Why don't we?
Yeah, go ahead and pull up Bob's offer there.
Prism
Okay,
1
sure.
offer.
So I'm Alice in this environment, so I'm going to scan that offer and pay 1,000 sats here, and then we should see some payments come in. So we see the 1,000 sats here, and the downstream Carol has received her share as well, but it's minus the 20%. Well, it represents her entire share minus that 20% that was paid to self. So anything else you'd like to say?
That's about it.
Okay, I think we're done.
Thanks, guys. Do the judges have any questions for you?
Is there a way to make it because I think the original first node is costing all the funds and then sending it out. So a way to do it non-custodially?
That is not something we're considering. There may be a way to do it non-custodially. The way I like to explain this is that you can run the Prism as a non-custodial use case. So it can be custodial if you're taking funds on behalf of others, but you could also use Prisms to automate your cash flows, for example. Any other? Yeah.
Okay, I'm up next representing Lolly, who could not join us. Okay, so what Lolly is working on, and I'm presenting on his behalf, is a attempt to take Bitcoin script and write a formal specification for it in a, forget the name for this, I think it's in here. It's Alloy, which is a lightweight formal model, kind of like modeling language. So basically this allows you to create assertions about how script works and kind of create a formal model of what the relationships should be and what the constraints are around different actions that happen in script. What's really cool is if you're able to build this formally specified model, you can make assertions about current scripts, and it lets you, I believe, experiment with adding new scripts. So this started at the hackathon, which is super cool. It's pretty early, so the script that Roast Beef was able to accomplish is pretty basic. He's got pretty good set of comments on it, so it's kind of interesting to read through and just look at what he's doing. I think the current implementation is at the point where it's making a formal model of what's allowed and not allowed around movement and data pushes both the stack and the alt stack. So he's got to alt stack and from alt stack in here. And limits around how big a stack bytes is allowed to be. Everyone recognize this 520 byte thing now? That's a question. Yes, I can do that. Good. Okay. So basically, what you do with like formal specification languages, I believe, is you kind of figure out what all the limits are around different pieces and what the interactions are, and you formally declare them in the language. This is again in Alloy, and then I'm not exactly sure, but then you can run basically an analyzer on different actions and make sure what you're doing is allowed or not allowed based on the constraints that you've specified. Cool. Okay. I think that's the whole thing. Hopefully, Roast Beef is watching on the live stream, so it hasn't sent me any messages. I think we're okay. Great. Okay. So what the goal is to be able to model Bitcoin script in this like virtual machine using the Alloy framework. Ideally, it'll let us research new costs of adding new opcodes, etc. And it's cool because you can use these new. There's a recent version of Alloy that got shipped, number 6, which includes facts, assertion, scenario, temporal logic, etc. Cool. Okay. Any questions? Great. All right. Cool. Thanks, guys. Next, we're going to have Bolt 12 offer decoder. This is Gas Runes, feeless transactions.
All right, hey guys, so this is gas runes. I'll try to cut it short and sweet and give you a bit of the context. So in Ethereum, we have this notion of meta transactions or gasless transactions, which are required to kind of onboard grandma, your kids, or dog. And Polkadot has this notion of block NFTs. So they're able to sell kind of NFTs of block space into the future. And Rydell yesterday, the day before yesterday, was talking about paying miners with runes. We took that idea and kind of merged it with what we were thinking about and saying that instead we can create a secondary market where relayers can grab some of these transactions that contain no fees or very little fees and then allow them to relay through CPFP. Endless possibilities with covenants and other meta protocols. And in reality, the reason why we want to do this, or we're doing this entire thing, is because we want to educate and also expose other folks in reality what's happening with ordinals and meta protocols, right? Because who's really buying these ordinals or runes? It's the Solana boys and other people. So we did spend a few days writing a paper which we're going to publish, and it's focused around this context, right? And all this stuff is possible when we have Bitcoin Core V27 and 28 and V3 transactions overall. So this is the overall TLDR. So you have an ephemeral anchor that contains a rune or other fun coins. It doesn't have any spending, and then you can essentially broadcast it, and then anybody can pick it up and use a CPFP to sort of relay it or pay or bump up the extra fee. So there's different kinds of schemes that we've been looking into. One of them is a side channel scheme, which will require a quote-unquote another kind of mempool or meme pool. And then otherwise using kind of similar to what has been proposed with V3 transactions, having a little bit of dust. But yeah, that's really the short aspect to it. Currently, we do have some transactions working. We have a little client that shows you the transactions and also allows you to compare against rune prices, because if you're going to relay these transactions, you want to understand how much is the fee rate versus the price of the rune, right? Because you're kind of speculating on this aspect. But yeah, long story short, thanks to Cube, they came up and shared their API very last minute, pulled it together, and we use Hero Systems. But
yeah, so kind of quick, just show some code that we did here. Assuming this will work. So I wanted to just go through kind of what we did here, because we didn't actually get the code to run with the demo, but I thought it was pretty cool. So we built a PSPT here with some phony inputs, dead beef, cafe babe. This is just these are our fun token input, the first one there, and then our real input that we want to send someone else, and the second one there. So the first one is just going to get paid out to an op true there, kind of in the middle of the screen there, so we're paying out to an ephemeral anchor. In this case, we send the entire inputs to the 2 outputs. So one input goes to one output, second input goes to second output, and that lets us then attach an anchor CPFP to the first output, and that's going to get whatever fun token was on that first input, whether it be a rune or an ordinal or a rare sat, whatever fun token might be there, the first output's going to get it. So in this scheme, this is the no new meme pool, so we can use the existing meme pool to do this. And so we put in a CPFP that's going to pay a minimal fee rate, relay fee rate 20 sats per vbyte here. That's just going to let us get through the meme pool out to others who could see it. They can then scan their local meme pools and see that there's this low fee transaction that happens to have in an anchor output some valuable token that they want to grab. So then they go ahead and make this higher fee, 500 sat per vbyte CPFP, and bam, they get to claim that. So I can now show this actually running. And so we see this is kind of the sequence of transactions we make. The first one has 0 fee rate. Then we replace it with a package fee rate of 21. And then, or sorry, we initially broadcast it with a package fee rate of 21. And then finally, it gets CPFP'd to a package rate of 501. And that person gets to claim the valuable or non-valuable or whatever fund token that was attached to the first input. And that is about what we got.
Yeah. And the cool part is really at the UX experience that we can afford to Bitcoin, but also the aspect of really the game theory and economics behind it. Because currently most people are using runes and ordinals to speculate, but now they can actually perhaps be able to contribute to a better experience overall. So we're probably going to publish a paper over the weekend to hear some thoughts and also hear more about different schemes that people can do. But thank you.
Do we have any questions from the judges?
Is there a link for some of the paper stuff that you built?
Yeah. It's in the repo.
Okay.
On the GitHub. Yep.
Are those shared with us?
Just posted them in the shared Bitcoin ++ judging
It's probably in a separate
spreadsheet.
branch. Yep. So a lot of the content is really literature review because the way we write in is because when you look at people freaking using runes or ordinals, they're not Bitcoiners, right? And so they don't understand about spam and everything else. So the paper really talks about the contracts and how this works. And I love my Solana friends, but really it's particular to them, so they understand how the mechanism works and also the impact on these decisions that they're making. But yeah, it was fun. Thanks.
Yep. Thanks, y'all.
Awesome. Thanks, guys. Let's give it up for gas runes. All right, next up we have Bolt 12 offer decoder.
All right. Hey, everybody. My name's Nick. My project called bolt12.rocks. So if you're familiar with this web-based Lightning decoder right here, I use this all the time in development. It's really good for decoding Bolt 11, LN URL, Lightning address. But as we start to see Bolt 12 become more prominent out there, I think 3 or 4 of the projects were using it. As a developer, we want a nice web-based decoder. If you're not familiar with this, you basically just paste in your Lightning invoice, and it shows you basically what chain you're on, how much it is, the invoice, a bunch of different stuff about that. So if you've ever been to bolt12.org, it's an awesome site. It shows you how Bolt 12 offers works, but the decoder doesn't work. So if you actually try to decode this Lightning offer, it essentially throws an error. I don't think it'll even work. So I decided to basically build my own. So that is out here live on bolt12.rocks. So let me grab a Bolt 12 offer. So I'm actually running LDK node here. This is brand new. I'm running on a Bolt 12 branch. So let me just type in get offer. Let's get a 2-set offer. Bitcoin ++ rocks. So I'm doing a lot of Rust right here. This is my first weekend learning Rust. Shout out to Jeff from Spiral for helping me. Yes, I'm a Rust dev now. But anyways, long story short is I get this offer. So let me paste it into my decoder, and let's see if it blows up or not. So you can see it actually decoded the Bolt 12 invoice. And the super interesting part about Bolt 12, kind of for privacy, it helps with the receive side privacy. And it actually shows some of these blinded hops and these introductory node points and blinded points. I wasn't able to go through the entire, decode the entire path, but there's an array of all these. So if you have a bunch of different, you can scramble your route essentially. So yeah, I think this is pretty much where Lightning is going with Bolt 12, and I'm pretty much really excited about all this stuff. So yeah, I'll post all this code. Right now it only works. I used LDK. I think Core Lightning and LDK have a little bit of compatible issues with Bolt 12 offers, but I'm excited to see kind of the future of Bolt 12. That's it. Thank you.
Do you guys have any questions for Nick? Awesome. Oh.
No, I don't know Rust, so I was just not knowing Rust. Yeah. Yeah, Rust was the hardest part. But I mean, after that, I was able to, LDK node is just a CLI-based tool right now, so I had to like wrap it into my own REST API, and I exposed that for the front-end app to talk to. So that was easy, but yeah, just learning Rust to decode stuff, like I don't know Rust. Anyone can learn it if I can learn it.
Great. Up next, we have I Still See You.
Hello. Yeah. Yeah, so our project is I Still See You. We know that BIP 324, the P2P v2 encrypted transport, it was included in the latest Bitcoin v27 release, and it allows for pseudo-random encrypted communication between the nodes. So before, if nodes in the P2P network send a transaction, the global passive observers, like internet service providers, could be able to take the packet and see what the plain text content of the transaction is and infer who is transacting with whom. And BIP 324 solved that by making it all pseudo-random, but it still didn't, and that's what we have in v27, but it's not a complete solution. There are still stuff like length, which is basically the metadata, which can still leak information about transactions. And for example, if you see these nodes, you can see the pink thing. Imagine it's the transaction message. Just because of the different lengths, you can identify one transaction from another, and you'll be able to differentiate it just because of the metadata leak. So we want to do even better. We want to hide the transaction length. And so one easy thing we can do is basically pad messages. And you could pad all the transaction messages to some size so that no one can differentiate one transaction from the other. And we did some stats, we scraped data from the last 100 blocks, and we also scraped data from mempool, and we kind of got those percentage stats, and kind of decided to, you can see that most of the transactions are below 1,000 bytes. In the last 100 blocks, 96.7% of the transactions were below 1,000 bytes. 99% of the transactions were below 3,000 bytes. And in the mempool we had, 89.6% were below 1,000 bytes, and 92% were below 3,000 bytes. So we can pad them.
Yeah, so we tried a couple of approaches. So for the fixed size data, we fix at 1,000 bytes. So let's say if your transaction is below 1,000 bytes, so we pad it, make it 1,000 bytes. So the extra bandwidth that was required came out to be 43 MBs for the last 100 blocks, including all the transactions. And let's say if we increase to 3,000 bytes to include more transactions, we see it quadruple to 162 bytes. Now we tried using a dynamic sizing algorithm, Padme. It turns out it didn't do really well with a larger set of database, and it turned out that we required a total of 111 GBs of extra bandwidth. When the set was smaller in mempool, we see the results were pretty consistent, and Padme was able to perform really well in dynamic sizing, given the number of outliers were less. So the crucial point was handling those outliers, because the largest number of transactions we were able to handle in both the cases.
Yeah, and Padme is this really cool algorithm. It's kind of like an in-between way. For example, in Tor, you pad everything to 512 bytes. So there's always this fixed size bytes message which is sent. And the other extreme which you could do is basically pad everything else to the next 2 power whatever. And there's a paper which does this, and they kind of looked at the efficiency. If you do 2 power bytes, this is the red thing you see is the padding overhead, and the green thing is the padding overhead if you do it Padme. But as he said, it's good for small sizes, but not for
the outliers.
Outliers. Oh, where is this? Yeah, so something else we want to do is also just to handle the outliers. BIP 324 has a provision to send decoy packets. There's an IGNO bit which can be set. So that's basically for handling the outliers. We could send those packets with those kind of length of transaction data and fool people to create fake transaction spikes and fool people to think some other transaction is being sent or something else.
Yeah, so the kind of conclusion that we came out with is that fixed padding was able to be pretty bandwidth efficient, but it can't really hide the outliers which come in with the coin joins. But yeah, so yep.
Thank you.
We have time for one question from the judges if you've got it.
Just so I'm not super familiar with it's 324, is that the?
Yeah.
So the idea is basically that encrypts the information, but so you can't see the transaction data, but because of the size, you can start inferring information. So this is an additional layer to the protocol so that you can't infer that anymore.
Exactly.
Okay.
Transaction is sensitive data.
Yeah. And even transaction size. Like the data itself is hidden already, but the size itself can give stuff away. And then you can infer like what scripts might be being used. And so part of the proposal is there's a table with different padding amounts. Is the idea that it could be one of those padding amounts, or you're just analyzing the different options? Or would they all be padded by the same amount, to the same amount?
Oh, those are like 3 different algorithms. Like we are trying to find we were analyzing the different padding algorithms and seeing which one would be a better choice.
Yeah, because one of them is like, you pad to 3,000, so that adds more data, but you can't do 1,000 because then you're exposing the ones that are bigger than that, right? Which is still like 12% or so.
Yeah, like even though 3,000 covers a large percentage, it's too much bandwidth, so maybe 1,000 is better.
Right.
Yeah.
Cool.
Great, thanks guys. Let's give another round of applause for I Still See You. Next up is our Bolt 12 Covenant Zapper. If you guys could proceed to the stage and get set up.
Hello, Bitcoin Plus Plus. How we doing? Enjoying the demos so far? Yeah, lots of great stuff being built. All right. How do I
change the mirror?
There we go. Is it doing stuff? Keep changes. All right. Yeah. My name's Chris Guida, C. Guida. This is Damien, also known as Good Enough. We are the Bolt 12 Covenant Zapper. We decided that Bolt 12's time has come, and people need to start adopting it because it's awesome. If you haven't heard of Bolt 12, it's a little bit like LNURL, except way more cypherpunk. It actually just keeps everyone private, and it's like infinitely extensible, and it's awesome. So we decided that maybe one of the best ways to get people to adopt Bolt 12 would be to add it to Nostr. Nostr has a thing called Zaps, uses LN URL under the hood and LN addresses. I don't like having to trust the third parties with my Nostr profile, so we're doing Bolt 12. All right, so we made this nice GitHub repo here. The reason why it's a Bolt 12 Covenant Zapper is because we're concatenating every Nostr event until we can introspect the Bolt 12 offer committed to in a recipient's kind 0 metadata. So basically, all we've done is we've extended the kind 0 to put a Bolt 12 offer there. We forked a bunch of upstream things. We forked No Strudel, which is this cool Nostr client here. We forked Bitcoin Connect, and we also forked another thing, which I forgot. And Damien has an NWC thing. Yeah. Oh, yeah, we'll see that.
How do you scroll up here?
Yeah.
These are all our
Bitcoin sorry,
Connect.
Yes. Yes, okay. These are just things that Damien has already written. So Damien's been doing, you'll see, I don't want to give it away. It's pretty cool what we were able to get done. Cool. All right. So the first thing that you want to do is you want to make a Bolt 12 offer. You can do this using Core Lightning, offer any test, and some other stuff. And then you want to copy your Bolt 12 offer into your profile, which you can do here. So update. Albi is going to show you the event. As you can see, the event has this kind 0, and it has this new thing called Bolt 12 offer. We confirm. We sign that with our Albi. And so now we have a new Bolt 12 offer in our profile. We just go to the profile, and you can see I've got that there. And I think that's it. I'll turn it over to Damien.
Yeah.
Sorry, that's it for me.
I'm gonna
now it's the next
switch
part.
over to my screen here.
Oh, there's two. Okay, great. That's really fancy. All right.
So I got on our fork of Nostrudel here, I got Chris's profile up, and you can see his profile now has this Bolt 12 offer in it. So we want to be able to zap it. So what we did was forked this Bitcoin Connect button, and we added an option to connect with CLN REST. So we're going to need a rune and a CLN REST host. So I need to start the plugin. Here it's somewhere. Start CLN REST. One second. CLN REST is started, and Chris and I are on a local Registess environment. So I will create a rune here. And now I can paste this rune in here and the REST host and connect. And now I can go back to Chris's profile and zap him. We will zap 17 sats. And if I go in here and say list pays, see I just sent 17 sats. So that's option one, but that requires you're running a Lightning node and you need to connect to it. So we also forked into Nostrudel this cashew tab. So you can connect a cashew mint. So if I do, I'll start up my cashew plugin. So now the cashew plugin is running. I just need to stop CLN REST and start it again so that it can register that. Why doesn't that work?
Plugin start, right? Oh, yeah.
Okay,
probably
CLN
'cause
REST
it's not
must have
running.
crashed.
Yeah.
Yeah, CLN REST keeps crashing. So we'll start CLN REST again. And so now it's going to be at the same host.
Yes.
Thank you. We can add this mint, and now we can mint some tokens. We're going to mint 100 sats. So now I just need to use my L1 node to pay this invoice, and then say I paid it. And now my balance is 100 eSats. So I can go back to Chris's profile and zap him some sats with this button here. And this is zapping right to his Bolt 12. And you can see we just sent 50 sats there. And now we have one more option. With this NWC plugin.
We decided to enable all of the methods of connecting because Bolt 12 needs to happen.
So this is an NWC plugin that I made that we've added in Bolt 12 functionality. So I can say NWC create, copy this Nostr Wallet Connect, and now in my settings, I'll use this Bitcoin Connect button, and it already has the ability to connect with Nostr Wallet Connect. So I can connect in there. You can see I'm rich. And now I will zap him again. Let's do 70 sats. And it paid. 70 sats there. So now you can zap someone's Vault 12 with any method you want.
Very cool. Great.
Thanks.
Do we have any questions from the judges? I think we only have time for one question. Awesome. All right, let's give it up for our Bolt 12 Covenant Zappers. We have Validity's up next.
Thanks, guys.
Up next, we have Validity.
Am I live?
Yep.
Okay. So this isn't your typical hackathon project. It's really the first steps of a journey that I'm on, and it may not be very exciting or sexy for many of you, but I think it's kind of cool. So Validity is a project to put the validating Lightning signer component inside of a trusted enclave. And so it's a brand new project, and I'm going to be working on it for the next year. But my goal was to get a blind signing SecP256K signer running inside the opt trusted enclave. And what I've been doing is building opt and creating a build procedure for opt. I also made this block diagram of the overall architecture. And this shows how, basically on the left, in the top left, you see the Rust CLI app that will talk through this. I don't have a pointer, but it goes down through the stack and comes up to the top right, which is the signer TA, and then it comes back. And the bulk of the work that I've done today is this install procedure, and this is all on the website, to install the package. And if I switch to, here it is running. This is building a full Unix userland, a kernel, all the BIOS. And when I'm doing this with the latest version of opt, I did this in the fall with an earlier version, which I can show you really quickly. If I run it under QEMU here on my Mac, oops. Oops, hang on. I have to run two listeners here. This one will have the, oh, geez, what am I doing here? $54,321, 54,320. Okay, so we listen. This listens for the console. This is the debug log for the trusted environment. Now, if I run QEMU, it should boot up. Here you see the log. And now we're running unit tests. Pretty exciting. That's all I got. Thank you.
Are there any questions from the judges?
Is this like a SGX competitor that you're running it in?
I'm running it in ARM Trust Zone, which is in some ways similar to SGX, but it's more focused on running what are called trusted applets inside of the enclave, sort of globally for the system, whereas SGX is often used to do attestation on processes that are bigger processes that are running in user space. Although the latest ARM hardware has a thing called confidential computing architecture, which is more similar to SGX.
Cool.
Great, thanks, Sean. That's awesome. And this is Insane Bolt.
Hello. Hey, all right, cool. So we're like looking at some of the other presentations. We're like, wait, we did some of that. Okay, anyways, you're going to see some repeat here. So hopefully you don't snooze this. But the question that we're kind of tackling is, how can we enhance games with better Bitcoin UX? And if you remember Satoshi's Place, I would say most kind of like Bitcoiners that were doing Lightning early days, you know, whatever that means, early days, but a lot of people came in here, bought some pixels, and I think this is kind of special. how can you, what's like the first place that you can go and have fun with the newest technology, right? And how can you gamify this? How can you prototype this? And I think games is a great place to do. So we are bringing a couple of different things into the picture, including Bolt 12, Master Wallet Off, stuff like this. And I'm finally feeling like this has kind of been repeated, that Bolt 12 is finally creeping into the picture, like we're seeing with Prism and stuff like this. And you're not allowed to cheer. We're up. You're our competition. Shush. All right. No, I'm just kidding. No, that was impressive. So we're finally seeing, everyone calm down. Or we're finally seeing Bolt 12 finally enter the picture, right? We're finally seeing like some people use it. We're seeing implementation support it, LDK, LNDK, Core Lightning, all these, finally usable. So we're like, okay, we're going to enhance games with Bolt 12, right? That's going to be one of the things we're going to focus on. Christian's like, I got you. No need to sync a node. POC, hackathon, you can use my node. Bam. But yeah, he's like, psych, this is a hackathon. Just played you. I don't have a node for you. Corrupt, whatever, that happened. Then we're like, okay, how can we sync a node fast? Because, we're going to use mainnet, obviously. Duh. And then we were like, okay, hey, we can actually sync a node pretty quick with Trusted Coin. We found this thing. It's like, oh, wait, we work with this guy, Fiat Joff. We're like, oh, we didn't even know you made this. It's like in our repo. So we're like, oh, this is a core plugin. Cool. We're going to use this. And we're going to use it for the backends. And then we're like, wouldn't it be really cool if we got Core Lightning and LDK to be interoperable for Bolt 12 offers? And some may say, this is a hard routine. Checkbox. All right. And yeah, but right, if anyone's paying attention with Bolt 12, that's not really possible right now, right? So we decided to go, we'll say the safe route, right? Core Lightning. Now I will say LDK was really fun to learn. It was like, that was new for us to dive in and look at the sample code node and then the Bolt 12 branch and stuff like that. So that wasn't a waste of time. I think that was a lot of fun. But we ultimately went Core Lightning. And then last night, we were battling pip and Python, and I really want to appreciate everyone who helped and decided to help us install Python on Ubuntu 24. So thank you for that. You really helped this hackathon and didn't slow us down at all. I really appreciate the help. And yeah, we're so fucking back. We have both nodes set up now. Mainnet, let's go. So Bolt 12 demo, TMUX. So Danny, raise your hand. Danny is on our team, and he's going to be going through the demo. So we have sender receiver right here. You've never seen a Bolt 12 offer today, so this is going to be the first time. Let's go. Danny, do you want to run demo? Okay. So maybe I'll like kind of talk about what you're doing. So we're using the Lightning CLI, making an offer with a message. Here we have, so you can notice the L and O representing the offer. Looks like he's going to copy that. We don't actually know what Danny's going to do. This is all live, guys. Yeah. For the live stream, we have Danny off stage. And then we have another node here as the sender. So if you remember, for those aren't familiar with Bolt 12, I know we kind of went fast through it, but whoever's making the offer is going to get paid. Okay? This is audience participation. This is yeah. Fetch invoice. There we go. See? Boom. And if you notice the invoice right here, it's LNI. So that's something to note for people familiar with Lightning, right? To differentiate quick glance. Yep. General effect, Yeah. I need to pop in the mic. All right, so there we go. Completed. So this was. Thank you, Danny. And this is a lot of fun because we got Bolt 12 offers working. We proved it can work, right? We're going to go real quick back. So then we're like, how can we? Okay, now we know Bolt 12 offers work. How can we bring this to games, right? And this is like a decision between like, well, in a game, like you usually have a game server. If you have a game server, why do you need Bolt 12 offers if the receiver, like the game server, can just dynamically create Bolt 11 invoices? Like, where does offers come in? So what we decided was offers really come in terms of refunds. So it's like bring your own offer. So if a player is coming into the game, they have an offer. Then they give it to the game server to then get paid back later. So that's what we decided was the rational approach of how to integrate Bolt 12 offers into games, not from the actual server side, but from the player side, okay? Just to let you know a little bit of our decision making here. And man, have you ever heard of this, like metadata in a kind zero, like Bolt 12 field? Isn't that crazy? Now, there is a big mistake that some people make. They call it Bolt 12 offer. We actually shortened it to Bolt 12 to save space on the network. So we're actually saving bandwidth on Nostr. Just remember that. It's just Bolt 12 without the offer. So way better for the environment. We care about Nostr's health, so just remember that. All right, and then you have to ask yourself, if you have a game player that might be a pleb, right, and you want to help them with offers, it's already, like, we already have these hurdles. We need like a really good website to add that Bolt 12 offer to their metadata, right, to their kind zero. So we had a website that SuperTestNet showed us. It didn't really quite work, so we actually decided to make our own website. And the cool part is you can add any field, not just Bolt 12, but you can add Bolt 12 offer, right? You can point people here to add stuff to their field. So I'm logged in right now. I'm actually going to refresh just in case this is like stale. Okay, and I'm going to add a field, JavaScript alert boxes for the win, Bolt 12. And then I'm going to add, let's add, I had an offer that I really wanted to use. This is secret, everyone close your eyes. Okay. And I want to add this offer to my profile, so I'm going to save. Okay. And then if I refresh, it should pick up that Bolt 12 as part of my profile, or maybe everything just crashed. It's going to work, hopefully. Oh, cannot read property of undefined get relays. All right. Wait. Okay. Nostr works 100% of the time, 50% of the time. And I just need a refresh. There it is. Boom. We have a Bolt 12 now added to my Nostr profile. And then what does that look like in terms of a game kind of receiving that? Well, you log in. Yeah. Dude, stop. And then the question is, okay, what's a logical way for a game to interact with that? Well, store it in the Redis session for that user session. And if this worked, bam, right there. The Bolt 12 offer is part of the profile of the user. So this, where is it? I thought it, boom, right there. So the Bolt 12 offer that we added to the Nostr profile, kind zero, is now in the Redis session for that user. Now we can use, that user can play the game now, and we have access to pay that person out.
Guys, okay, cool, that's time.
All right, let me. We did have one person that couldn't make it, L, and I just want to give a shout out to L. She wasn't able to make it in person, and yeah, we also implemented Nostr Wallet Auth. Thank you for all the help. Yeah.
Do we have any? We want time for one question from the judge. There's one.
Michael, could you get me some more popcorn after you're done?
Great. Okay. Thanks, guys. Up next. Cool. All right. Let's see what the Frosty Music team has for us today.
So we're the Frosty Music team. You might be wondering what that is. Well, Frosty Music is where we're going to embed a Frost key in a music key. So let's say you have like a music 2 of 2. We're going to have one of those music keys is actually a Frost key, which is a 2 of 3 T of N. So Jervis is going to explain how that works.
Full disclosure, no one should use this. We have no proof this is secure, but we just wanted to kind of Leroy Jenkins this. Anyways, we're going to assume that the EKG has been done, and right now it's really just about assembling the signatures. And we're going to start by looking at sort of the Frost setting here. So let's assume a 2 of 3, or at least n is equals to 3 here. We've got Alice, Bob, and Charlie. R refers to some kind of secret, and big R is the commitment. You'll notice that there are 2 indices there. The first digit refers to sort of identifier, a participant index on the music level. And the second number refers to a participant index at the frost level. So hence you see 1-1 for Alice, 1-2 for Bob, 1-3 for Charlie. So you will first do the usual stuff, which is where you would hash the commitments. They'll exchange it with each other. And now, each party would have a tuple of their hashed commitments. Then they would also do another exchange where they finally exchange the R11, R12, and R13 with each other. And they basically verify to ensure that the commitments checks out. And once that's all verified, they multiply it together to produce R1, which is the aggregate nonce for this at this particular level as this music participant. So now we're going to zoom out to the music level, and we're going to assume that Alice, Bob, and Charlie here are part of Acme Inc., some kind of organization of sorts. We talked about how they just produce big R sub 1 here. We assume that Globex is some company. They might have a threshold thing or whatever. We don't really care. We assume that they also have this commitment ready. This looks a lot like what we did at the frost level, and quite honestly, it is the same thing. We hash the commitments. We exchange the hashes. We verify them against the commitments. And then we produce what is basically another aggregate nonce here. Then now when we go to sign, what essentially needs to happen is Alice, Bob, and Charlie would create the aggregate public key. We didn't really see the symbols X sub 1 or X sub 2 or A sub 1 or A sub 2. They're just public keys that were already exchanged in DKG. So just assume that these were things that they already had. We compute a challenge by hashing together the aggregate public key. Since Alice, Bob, and Charlie belong to the music participant index at 1, we put R sub 1 in there with the message we want to sign. And then Alice, Bob, and Charlie would then individually compute the Schnorr signature shares, as you can see here. It's a little small, but yeah, trust. So they will compute, as sub 1-1, sub 1-2, sub 1-3. They would then exchange it and compute, the signature share S1. So once that's done, we kind of, at the bottom third of the screen here, we zoom back out again to the music setting, where Globex, maybe another organization with a threshold of their own, would have also produced their own little signature share S sub 2. And essentially, to construct the signature together, we sum them. So we take S sub 1 plus S sub 2.
Yeah, so you might be wondering, why would we actually want to do this? So let's say we have a Taproot Lightning channel. Well, that consists of a MUSIG 2 of 2. And let's say we want our signer, instead of to be like a single sig hot wallet, we want our Lightning signer to be some T of N signer. Well, one or both parts of that Taproot channel, they can have their key be a frost key. And so now in Lightning, we can actually have multi-sig signers. And in addition, we can use our Frosty brews, where any one of these frost keys can add and remove participants, can move the threshold around, can rotate their shares, can repair shares, all without having to close the Lightning channel. So we have much more powerful Lightning signers with this. Another application you might want to do is, let's say you want 2 different quorums. You want to require 2 different quorums of signers to both participate in signing. Let's say you have a set of servers and a set of humans with HSMs, and each of those has a different T of N configuration, but you want to require both the humans and the servers to sign. So you could create like a MUSIG 2 of 2, and a frost key with the servers and a frost key with the humans. So there's at least a couple of applications. Future improvements, right now we're working with MUSIG 1 because we didn't want to have to deal with the dual nonces and the binding hashes and all of that, but we know it will work with that. It just required less time to implement with MUSIG 1. We've got some code here in my Python Frost implementation in the Frosty Musig branch. And let me show you a quick demo. Unfortunately, we didn't have time to actually sign in a Lightning channel, but we've got a test here where we are going to do a Frost DKG in the setup. The Frost participants are going to generate nonces. The Musig participant is going to generate nonces. They're going to aggregate the public keys, aggregate the nonces. They're going to sign this message. And then we have a verifier here down at the bottom that will verify whether or not this is a valid BIP 340 signature. So if we run the test, we can see it passes. We're not just getting lucky with the Y coordinate. We are actually dealing with 32-byte keys here. So if we keep running this, and you might say, like, well, you know, is this my janky verifier? Like, is that actually like correct? Well, we have the BIP 340 reference implementation here. So I'm going to plug in the signature we produced. And the public key. And our message is already set. And if we run the reference verifier, you can see that the output is true. So we're actually signing valid BIP 340 signatures.
Awesome. Do we have any questions from the judges?
Just for my own curiosity, like what is the, like what, since there's like lacking security proof, like what could be insecure about this?
I mean, I think almost everyone's convinced that it is secure. We just want to prove that's secure. But if it was not secure, then you could potentially forge a signature if the scheme, you know, isn't secure. But it would be very surprising if that were the case.
Cool. Nice job.
Awesome. Thanks, guys. Next up, we have Blogster and Magster.
All right. Hey, everyone. So what is Blogster? So I published, or basically I'm fetching articles over Nostr, long-form content events. And then I added lightning tips. I fetched the profile metadata and basically produced like an LN URL pay. And you can think of this as like personal blogs, but instead we're using the Nostr network instead of a database. So if you publish content to like obla.news, you can also use it for your personal blog. And why might you want to do that? Well, censorship resistance, you can send it to multiple relays. You can get communities using Nostr without even needing to know Nostr. Value for value, and we have like a lot of people in our community that was asking for this. We have like marketers, and they want to produce content and bring more people into Nostr. So why now? So I mentioned the first point, we can also disrupt publication incentives. So typically like publications will offer like $50 to produce an article. Now you can produce content and receive payments pretty easily. Nothing too novel there. But then you can also get more of the internet off of these like massive platforms like Medium and move to their own platforms again. So here's the demo. You can see I am fetching each Nostr event, and I built this Nostr service here that is actually fetching all of the articles as well as the article details. So I built it like pretty modularly. And you can see this is my NIP05, the date that I publish it, the title, and then the image from the article. And then you can actually go in here and see all the details. So I fetched title, summary, NIP05, date, and then the lightning address. And then you can actually execute payments as well. against it. And so that's kind of Blockster, but you can also use it as another use case. So here I just set the hex pub keys in an array. So if I want to add multiple publishers and take this from Blogster to Magster, you can. So I'm just going to rename this. And boom, now you have multiple publishers on the application. Refresh. And here you can see all the content. It's completely dynamic. And then you can actually execute a Lightning payment. Boom. Yeah, so that was the project that I worked on. I hope this brings more communities to Nostr, ultimately, more use cases of the other stuff. Peace. Any questions? All right, thanks.
Thanks, guys. Thanks, Satoshi. Awesome. All right, next and our last presentation for this Bitcoin conference is going to be MSB.
Great. So you should all be able to see my presentation, which I've got two wallets up here that I'm about to do a coin join in. And let me just tell you a little bit about what I'm going for. Free samurai, right? The friggin' samurai guys got arrested for doing nothing wrong. And I want to free them from prison, but I can't really do that, so I'm just going to recreate CoinJoin software that the government cannot stop. How I'm doing that is using this serverless flow, which is a protocol I made while preparing for this conference. And then I wrote the software during the conference, so that's why it qualifies for the hackathon. But we're going to publish the inputs that we want to use to a public bulletin board. I'm using Nostr, as well as a change address and a pub key that we're going to use in a ring signature. Everyone who's participating in this coin join is going to validate the ring signatures and only let those people who have a valid ring signature be in the in round 2, which is where you publish a output that you want to receive the equal amount in. And then everyone sorts the resulting inputs and outputs lexicographically and broadcasts a transaction. Broadcasts the resulting transaction. So we can do this live on testnet, well, MutinyNet. So I'm going to click join on both of these clients here. And without having a coordinator, they are going to first do round 1, which should show up right here. It should say preparing for round 2. Yep, so that guy's doing it, and this guy is doing it. And in round 2, they are doing this part where they, well, this is kind of hard to see, but they are publishing their CoinJoin address and including a ring signature. So they just did that. And now they are validating the signatures for the Bitcoin transaction, and either one of them should show, or both of them actually, should show a Bitcoin transaction that they can sign, that has been signed by both parties. And so if I copy this Bitcoin transaction and broadcast it, which I will do, copy that, broadcast it, and there we go. That's a valid transaction. And it has coin-joined their coins. They have a different amount inputs, and they have 2 equal amount outputs, which are both worth 10,000 sats. And yeah, so those are those. And then their change is, one of them has toxic change right here. The other one has toxic change right here. And in the interface, it actually shows, if I X out of that, he has 10,000 sats that are free and clear, and then 5,530 sats that are toxic. And the other guy, similarly, has 10,000 sats free and clear and 10,530 sats as toxic. So it worked. We can do coin joins without a coordinator now, and the government cannot stop that. So we're great. And I was inspired to do this ever since the samurai people have been gone. So, any questions? All right, great. Free samurai. Thank you.
Cool. Let's have another round of applause for all of our awesome hackers this weekend. That was really great, y'all. guys, we're gonna go ahead and get started with the announcement of who's won, as well as I don't know, some final notes. But before that, do you guys want to give a quick pitch about Austin BitDevs?
Sure. Well, one of our co-hosts that's not here, obviously, right?
He's always leaving.
He's always leaving. Well, you were gone for 4 months. So yeah, I guess Austin BitDevs, we run it out of the Littlefield building on 6th and Congress, third Thursday of every month. If you've been to any BitDevs, either here or any other part of the world, very similar format. We tend to follow. We try and keep it very technical, so none of the social drama, Twitter drama, unless there's technical aspects to it. And we basically work through a list of topics of things that had happened in the past month or so, or even older if we miss stuff, and we'll try and introduce the topics and generally have really good conversations. So, and we have a lot of core developers, protocol developers that live in and around Austin. So Nifty is a regular, and Ben obviously, who works on a few different protocols that we talk about, but lots of others. So it's a really good time, lots to learn and discuss. Really all levels. There's people that are not super technical that tend to get a lot out of it, and then very technical people, and we can have interesting debates about how to move Bitcoin and the world forward. That's my pitch.
I mean, you got it pretty well. I don't know. I mean,
third Thursday of every month.
Yeah,
Come join us.
Come through. We have food as well.
That's right.
All right, great. Without much further ado, we're going to move into the section where we find out who's going home with the fabulous prizes. I have a little something. So if you end up winning, make sure after this that I have your contact info, and I will get you your prizes after the fact. I need to go dig out some coins out of various wallets to make that happen. So we will get it done offline, hopefully before we leave Austin this year. If you're in second or third, though, I do have a little gift for you. So if second and third teams can come up and get a little special print that we made. I think these are one of ones. They're the only one that we printed of this particular design. I think, hopefully I'm not lying about that. Okay. Cool. Okay, great. So again, thanks everyone for coming out for the 6th ever Bitcoin script edition. I know that I learned a lot. Hopefully you guys also picked up a lot of info or made new friends that you can ask questions to when you run across things that you don't know. Great. Okay, so in third place, can we get a little bit of drum roll, please? Have Gas Runes. So round of applause to you guys. Cool. So I don't have anything to hand you, but do judges want to say what you liked about this project, or are we just rolling through? We're rolling. Okay, great. In second place, we had Bitcoin Alloy, which is Lalu, who's not here. So I guess this is we're going to hold on to this to get to Lalu. So congrats to Lalu if you're watching.
We should get him to come back and pick it up in person and, on the third Thursday of next month.
Lalu, we're holding your gifts at BitDevs in Austin for you, so come pick them up. They'll be there next time you come to town. All right, and then last but certainly not least, in first place, we have Frosty Multisig. This is a project that was looking to shard, I believe it's sharding a Musig into a Frost signature. Is that right? Cool. So if one of you wants to come up and get this lovely print, I'll hand it off to you. Cool. Great. Come on up, Jesse. Yeah. Yeah, thanks. Cool. All right.
I love you all.
Oh, and again, thanks to our sponsors, Folger and TVP Fund, Trammell Venture Partners, I should say, that were contributed to making all of the hackathon possible, as well as giving out some great gifts. Okay, cool. So the last thing is, hopefully you guys all had a lot of fun here in Austin this year. We're super excited to have all of you joining us. We're hoping that you'll join us next year as well. I feel like I should say a little more about like how great a conference this was and how awesome it was that everyone came to participate. Should give a extra special thank you to Paul or XFrog for running all of our AV and getting our awesome live streams going with our amazing camera setup. So this is like super cool. I think also enormous thank you to Jack and Teresa who organized, ran, got all the lunches going. That's an enormous job. Keeping 200 people fed is like not an easy task, so that's really cool. And a big thank you to the rest of the volunteers that showed up to help make this possible, getting here at like 6:30 in the morning on Wednesday to get everything rolling before the rest of everyone rolled in. You guys, I've gotten just numerous amounts of feedback from people that came that you guys were the smartest, most helpful, just absolutely best volunteers they'd ever had to work with. So big kudos to everyone in the Bitcoin community for, showing up and really making this a memorable event. Great. Okay, I think that's everything. Hopefully, and I also a big thank you to all of our sponsors who contributed to making this possible. It takes a village to pull off an event like this, and without people who are willing to support what we're doing, we really can't make these things as awesome as they are. All right, great.
And one more. Thank you, Lisa.
Oh. Woo! Awesome. All right, cool. Hope to see you guys next year. We're doing it in Austin, and I think tentatively going to have a mempool edition will be next year. So if you want to give a talk on mempools next year, I'd love to see what you guys work on and what your projects are. Send me your best pitch about what you're working on and why that would be a great fit for Bitcoin++. I think I have launched the website already for next time, so if you want to go ahead and start getting tickets for next year, this QR code, depending on how fast my web server deployed, may or may not be working currently, but it'll definitely be working at some point in the future. Great. And again, let's have a great round of applause for everyone who came and speakers who came and talked about what they're up to. We're planning on going to Ellis Bar tonight, which is an outdoor venue. I'm not super excited about being outside because of the weather, so we might change the location. I'll post an update in the Telegram chat within an hour or two, so keep an eye on that. Hoping to see some of you around like 8 p.m., I think is when we're going to start hanging out. Cool. All right. Stay cool, y'all. Bye.